Hey students, welcome to your math lesson of the day. Now, before we begin, let's work on how to write the date in number form. Since yesterday was Thursday, what's today? What's today going to be? Today is Friday. Yay. And since, remember on how to write the number form of the date, we need the month, the day, and the year. So we are in the month of November, and I know you guys know that November is the 11th month of the year, so we're going to go ahead and put 11 down. Now, yesterday was the 19th of November, so that means today is the 20th of November, and we're in the year of 2020. So today is Friday, the 11th, 2020. Okay, awesome. Now, we have been working on how to read an analog clock. So I'm going to draw an example on my board. So you have to bear with me. Now, there's two hands on the clock. So there's a big hand, and then there's like a smaller hand. Now, the smaller hand represents the hour, and the bigger hand represents the minutes. Now, the hours are easier to remember because if the small hand was on a 2, it would be 2 o'clock, or it would be 2 hours and something else. But since if it's pointed to the big hand, minutes go by every 5 minutes. So, for example, if we start at 12, we have 0, 1 is 5, 2 is 10, 3 is 15, 4 is 20, 5 is 25, 6 is 30. Let me fix my 3. 7 is 35. 8 is 40, 9 is 45, 10 is 50, and 11 is 55. I'm going to move my 2 o'clock somewhere else. So if the big hand is pointing to 2, for example, it would be whatever the hour is. So if it's pointing to the 2, for example, and the big hand is also at the 2, it would be 2:10. Or if the big hand was pointing to the 4, it would be 20, or if the big hand was pointed to the 8, it would be 40. So the big hand is like every 5 hours, but once it's on the 12, that means it's like it just finished 60 minutes an hour, so we're starting a new hour. So for this example, since the small hand is pointed to the 2, it's the hour is going to be 2. I'm going to use a different color. And since it's pointed to the 12, it would be 0 because we're starting a new hour. So at 12, it's basically 0. But for example, what if I move my hand to down here? It's still pointed to the 2, so it'll be 2 o'clock. But remember, the minutes are every 5, represent 5. One number on the big hand represents 5. So on the 6, it's 30. So it'll be 2:30. Okay, we'll get more practice with this later on during our live classes, and then on Class Dojo we'll get more practice, but this is just to think about the hours and the minutes, okay? So on the small hand represents the hour, so if it's pointed to a number, it's going to be that number. But if a number is on the big hand, it's going to be every 5, it's going to be the numbers that represent in the blue. So if the big hand is pointed to the 1, it'll be 5, or if the big hand was pointed to the 10, it'll be 50. So, but we're just getting more practice with this, so we'll practice. Okay, so if you want to turn to your big ideas in chapter 3.7, we are working on base 10 frames. So if you look at this, we have 1, 2, 3, 4. Ooh, there we go. So we have how many blocks within this block set? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 blocks within a 10 base frame set. So if I was to give you guys an example, let me make a new one for you. We have 10 blocks, because that's the total blocks we have. But what if I was to color in like that many blocks? So if we count the green, how many greens do we have? We have 1, 2, 3, 4, 5. We have 5 green that are filled in, plus whatever, that makes 10. So we're trying to figure out what's the missing piece in this equation to make it true. So 5 plus something equals 10. So let's figure out how many of the blocks that are left. We have 1, 2, 3, 4, 5. We have 5. So 5 plus 5 equals 10. And also we can check our work by doing the reverse and a subtraction equation. So we can do 10 minus 5 to check our answer. And if we were to draw 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if we take away 5 of those, we have 1, 2, 3, 4, 5. How many are left over? 1, 2, 3, 4, 5. We also have 5 to show that we did our work correctly. We have 5. So that's one. We're learning more about the base 10 frame set. So that is just a practice problem for you guys to do. So let's try another example. So in this problem we have, we're gonna write our 10. So we have 10, but we're gonna say that many is filled in. So our total number is 10 because that's how many of the total blocks we have. But how many is filled in? 1, 2, 3, 4. 4 is filled in, so 4 plus something equals 10. We can use a subtraction equation, 10 minus 4 equals blank, or we can count how many blocks are left over. So if we count out how many is left, we have 1, 2, 3, 4, 5, 6. We have 6. 4 plus 6 equals 10. Now we can check our work using the number line, or we can do the number counting method. Let's do, so we have the add-in of 4 and 6. And we want to check to make sure if it equals to 10. So we have 1, 2, 3, 4, and then we have 6 over here. We have 1, 2, 3, 4, 5, 6. So let's count how many, what's the total number? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we checked and we got 10, so we know we did that problem correct. Now let's do another example. So for example, we have an equation is written out like 3 plus blank equals 10. And it wants us to draw an example of this equation on our number 10 base frame. So we're going to make a little chart. So we're going to have a chart that has how many blocks? 10 blocks. So we're going to make a chart with 10 blocks. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 5 plus 5 is 10. So we know we have 10 blocks. And then 3 plus something equals 10. So we're going to fill in 3 blocks. Okay, let's use red. So we have 1, 2, 3. And that's how we would write that problem in a 10 base number frame. But let's figure out how many, what's our missing piece right up here. So we have 1, 2, 3, 4, 5, 6, 7. We have 7. So 3 plus 7 equals 10. So let's check our work on the number line. So I'm going to draw my number line up here and do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, if we started on the add-in 7. I like to start on the bigger add-in because it's less counting work for me to do. So when I'm doing an addition equation problem, I like to put my number on the bigger add-in. So 7 is bigger than 3, for example. And remember, in addition equations, we're gaining more numbers, so we're moving further away from 0. So we're moving towards 10. But if this was a subtraction equation, we would be moving towards 0. But since the plus sign is in our problem, we are going to move further away from 0. So we're going to go up how many times? 3 times. So we go up 1, 2, 3. And look, we both have 10 to make sure that is correct. Okay, awesome. So now let's do another another example that we can check to make sure that our sum is equal to 10. So we have these addition equations. We have 5 plus 5, we have 6 plus 5, and then we have 1 plus 9. So we are going to check to make sure if those answers equal to 10. So remember, when you hear the term sum is the answer in addition equation problems. So the answer of 5 plus 5, 6 plus 5, 1 plus 9, those answers are called the sum. But if we had 5 minus 5, that answer would be called the what? The difference. So remember, the answers in subtraction equations are called the difference, while in addition equations, those answers are called the sum. So we're trying to figure out the sums of these addition equations and see if they equal 10 to see if it's true or not. So in this equation, we have 5 plus 5. Let's do the number line for this example. So we write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. That's kind of bad, but we're going to make it work. So it doesn't matter. We're going to start on 5 because we have the same add-ins in this problem. So we have 1, 2, 3, 4, 5, and we landed on 10. I know it's hard to see, but yes, we landed on 10. So 5 plus 5 would be true because that has the sum of 10. So I put like a little check mark to show that it is true. Now for this, the next equation, we have 6 plus 5. Now 6 is greater than 5. It's most likely going to be higher than 10 because 6 is greater than 5. But let's double check our work just to show that we, just to know. So for 6, we have 1, 2, 3, 4, 5, 6. And then for the next add-in, we have 1, 2, 3, 4, and 5. So let's count out the total dots we have in this addition equation. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11. Now, does 11 equal to 10? No. So this answer, or this addition equation, will not do because the sum is 11, not 10. Now for our next one, we have 1 plus 9. And since my number line was kind of bad at the top, I'm going to do the number line down here so you guys can see a better visual. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 1 plus 9. Now if we put our dot on the 1 and count up 9 times, that's a lot of work, right? So we're going to put our little dot on 9 on the bigger adding because it's less work for us to do. And we have to go up 1 time further away from 0 because we're doing addition. So we go up 1 and look, we landed on 10. So this problem would work because 1 plus 9 is equal to 10. Now I'm going to assign you guys some work to get you guys more practice on lesson 3.7. I know some of it's a review for you, some of it may be new for you, but we are here to learn and get better at it. But if you have any questions, feel free to contact me during my office hours, and I'll be more than happy to help. Thank you so much.